last problem, right? It says pliers are used to grip channel locks, really. Are used to grip a 0.3 inch diameter rod, right? So we've got a 0.3 inch, right, diameter rod. Knowing that two 60-pound forces are applied to the handles 9.5 inches away, determine the magnitude of the forces on the rod and the force exerted by the pin at A on portion AB of the plier. So it wants portion AB, right? So with simple machines, the key is just like frames. You break them apart, right? You bust them apart, and the free body diagram is the critical function, right? We've got a pin here, we've got a force acting here, right, on the what is this, a rod on the actual teeth, right, of the pliers or the channel locks, and it gave us some dimensions for it. So step one, right, just like we did with frames, we do a free body diagram, and it told us in the problem actually to use portion AB of the pliers. So thank God for the graphics, I can draw this. There we go, perfect, right? It's a good thing I'm an engineer because I wouldn't make it as an artist. We have a 60-pound force acting here, right? Free body diagram, we have this rod, right? We're going to remove the rod. Remember, when you're using these channel locks and you're gripping it, right? The channel locks is placing a force on the rod, but in the free body diagram, the rod is putting an equal and opposite force back on the channel locks, right? So when we remove that rod, this is a critical thing, right? This is where I see students make mistakes with the free body diagram. You want to replace this with a force acting like this. Here, not the other one, right? That's coming from here. That's not coming from, if that isn't here, replacing what the rod would be doing on it, it wouldn't be in a state of equilibrium, would it? So that's the critical thinking skill here. Other than that, the problem got way simpler than I thought. But these machines are interesting, right? How they transmit forces as input and output forces. I mean, think about the power of it. You know, not just with channel locks, but I mean, you could take knots off, right? But think like something we could never take off with our hands. But think about, I mean, ultimately you can get bolt cutters, right? And they're connected. In fact, I was going to give you a bolt cutter problem. I probably should, because it had a couple of free body diagrams associated with it. In fact, we may take a peek at that next class. But you know, with a 30-inch long handle on a bolt cutter, I mean, I can literally snap a case hardened steel lock and right, remove it, which is incredible when you think about it, right? The strength that's involved with input to output forces. I mean, you're talking about, you know, the problem that I was going to give you for the class. I remember the solution, because I'd done it in the past, was like 46,000 something newtons. I mean, it's incredible, right? Because it's the way it's transmitting forces. But look at what it is here, even, right? The final solution, I think it was like 475 pounds or something. So, needless to say, we have to finish the free body diagram. We have this pin, right? And I'm replacing that pin with two force components, right? It has zero moment, which we know, because if it did, we wouldn't be able to do that with it, right? Nice and easily. Maybe if you leave them outside the yard for a while and they rust up, and you'll lose that. Leave it on your boat for a couple weeks when that and so on. So we have, that's the free body diagram. So if I'm looking to solve for this output force here, which the book uses P and Q, so I kind of just stick with their notation on that. We place a force Q here. I could sum the moments at A and find Q. Sum of the moments at A is equal to 0. 0 is equal to 60 pounds times its moment on 9.5 inches, and that's generating a negative moment, right, with respect to A. Q. It gave us the perpendicular distance, 1.2 inches. 1.2 inches. Q, is that a positive or a negative moment with respect to A?
Positive.
it's a positive moment, yeah, it's gonna generate a counterclockwise rotation, right? Positive, so now we can simply solve for Q, we're gonna get a positive answer, and I think, I remember, it's 475. It is, 475. 475 pounds, and so that's that, right? We got it. So that's Q, and then it also asked us for the forces that depended out. At this point, we could sum the forces of X and Y. Sum of the forces of X is equal to 0, and we've got AX positive, right? Plus this Q has an X component and a Y component, doesn't it? Like that and like that. And they gave us this angle. That angle is also this angle. So sine of Q, right? 475 is Q, 475 pounds, and sine of 30 degrees. And yeah, I am both pointing in the same direction, right? So that's fine. AX should be that way, and it is. AX is equal to negative 237.5 pounds, which essentially means it's 237.5 pounds acting that way, right? And then we do the same for sum of the forces of Y is equal to 0. 0 is equal to 60 pounds down, and the Y component here is cosine of 30. So we've got 60 down plus 475 pounds cosine 30, and that's also acting down, right? And AY is acting up. That's it, good. We're gonna get a positive answer. AY, and it's equal to 471.4 pounds. Acting up. So the reaction at A, just like the others, we got 237, oops, 237. 237.5 pounds, and you have 470, basically double, right?
Isn't it up?
It is up, thank you. Let's put this over here. 237.5 pounds, negative, and then 471, like we said, essentially double. 471.4 pounds. So this should look like that. Absolutely. If these two are here and here, and that's got a Y component down, the Y component down, this better have a Y component up, right? And that's it. So we find A, and then we find theta X, right? And we're done. A is equal to the square root of the sum of the squares. We don't know this. It's 527.8 pounds acting along this line of action and sense at an angle of 471.4 pounds over negative 237.5 pounds. That drops out. Take the inverse tangent function. It's going to be about 50, oh, 63. 63.3 degrees. And that's that. Yep, that's it. So what do you think? Does it make sense? Any questions?